Let's consider two ionic compounds, sodium chloride and calcium oxide. In part A, we're asked which compound would you expect the electrostatic forces that hold the compound together to be the strongest. So when you're talking about electrostatic forces, that's described by Coulomb's law, which goes like this. Force is equal to K is a constant times the product of those two charges, charged particles, in this case cation and anion, over r squared, where r is the distance between those two charges. And you might be like, well, that's not the equation we used in class. You're right, the equation we used is derived from Coulomb's law, and that was the equation for lattice energy, which goes like this, where Q1 and Q2 are the charges of the ions, and r, again, is the separation distance between those two ions. So if you integrate the Coulombic force over some distance between the two ions, you can get the potential energy between those two ions. And the way that lattice energy is related is lattice energy is all that, the total of all that potential energy of all those electrostatic interactions in that ionic compound, in the lattice of that ionic compound. So what we're going to use here, the equation, because that's the one we've been using in class. And so we'll answer this question in terms of lattice energy, which now you know is derived from Coulomb's law. So same concept here, because we're dealing with the Q's. Sodium chloride, they both have charges of 1. Right, so sodium has a charge of 1 positive, and the chloride anion has a charge of 1 negative. So for sodium chloride, the lattice energy is, we're going to ignore K for now, just a constant, is the product of 1 times 1 over R. Now we're going to compare that to the lattice energy of calcium oxide. Right, so calcium is here, it's a 2 positive cation, and oxygen is there, so the oxide anion is a 2 negative charge. So the product there is 2 times 2 over R. Now the distance between the two are actually pretty similar, and so we can say the primary factor in comparing these two is going to be the numerator. So you can look up, and the lattice energy for calcium oxide should be roughly 4 times the lattice energy of sodium chloride. So now we can answer this question. The electrostatic force, or the lattice energy, of calcium oxide is going to be much stronger than for sodium chloride, and the explanation is because calcium oxide just has a greater charge. Now, one thing to note here is these are not the actual charges. When we say +1, -1, +2, -2, those are just a number of the fundamental charge, which so we can actually use the actual charges was discovered by Robert Millikan. If you recall the oil drop experiment, goes like 1.602 times 10 to the -19 coulombs. But we're not doing any calculations, so we don't need that, those specific values. Let's move on. B says the melting point of sodium chloride is 800 degrees Celsius and calcium oxide is 2600 Celsius. Does that support our prediction? Yes. Yes, it does, because in order to melt, the melting point of an ionic compound is directly related to the electrostatic force, or as well as the lattice energy. And because the Q's are higher, the charges are higher in calcium oxide, you would expect calcium oxide to require more energy, or in this case, temperature is measuring that energy. More energy required to separate that stronger attraction between the calcium cation and the oxide anion.